Hi there. Welcome to my live stream. Today I'll be basically I finished yesterday gathering a data set from my Raspberry Pi camera, and today I'll be using the images I collected yesterday, and I will upload them to Kaggle as a new data set. Before I do that, let me just set up something here. It's making a lot of noise. I need to make sure my PC gets a little bit of fresh air. A bit hot if you don't let the fans breathe. So I'm back now. I still can hear the PC, but I think in 5 minutes time it should be a bit cooler. I hope. It's summer now, so the computer is going to get quite hot. All right. So in the meantime, I'll do the boring stuff because no one is here yet. So I have here two folders, right? This is the old data set I gathered from the internet and from other data sets on Kaggle. I'm going to keep it because my idea is to actually mix it with my own data set. Okay, this one is my garden data set, which I finished gathering yesterday. So I basically I took some video clips I collected last year from the camera, and I took basically I used VLC to take a frame for each. Well, not every frame in the video, but I took like one frame every 20 frames or one frame every 10 frames. And I have a few images of birds. And then I have cats, plenty. So it's just under 500 cats, if not more. And I have also, so it's just a lot, 763 cats. The same cat most of the times. So I wonder how it's going to work with other cats. I don't know. I hope there is not many cats in my garden otherwise. But I don't think it will overfit because I'm using a pre-trained model, and this pre-trained model has been trained on many cats anyway. So it's not a big deal. And then I have foxes, right? I only have one family of fox, one type of fox in my garden, right? And they are probably from the same family. More than one fox, thankfully. So I'm going to. So these are my my pictures, yeah. So I'm going to use this, and I'm going to upload this to Kaggle, and then I'll explain a little bit more about what I'm planning to do on our coding session today. So today there'll be coding, which is nice. It's enough collecting data sets. So let me see, should I just take the... Okay, I'm going to compress this one. If you have any questions, feel free to ask. Okay, yeah, the computer is a bit quieter now, thankfully. So I have probably a large data set now. Okay. I'm going to call it just going to call it wildlife dataset. Now I'm going to go into Kaggle. This is the notebook, but before I do anything with the notebook, I'm going to just open a new tab, and I'm going to find the dataset I already created. Yeah, it already has a significant size. You can see there is I'm on version 4 here, and I'm going to create a new version. Yeah, I think you can see that, right? So new version. If at any stage, right, you can't hear me or something is coming out of the screen or anything you notice wrong, let me know. I'll be happy to get any feedback. It's just in case, yeah, you didn't see something properly. Okay, so I have to upload my images. Kaggle wildlife dataset. Okay, so it's 2 gigabytes. Wow. Seems like I made it significantly bigger. And it's going to take a few minutes to upload. It shouldn't take too long. And I hope it doesn't kill my live stream without the bandwidth that it needs to use. Should be okay. All right, so in the meantime, while it's doing that, let's just have a look. I'm going to give you a recap of what I did before, okay? So I might as well start. I'll start running this now. I'll run the notebook as it was before. I don't need to install the Kaggle, but never mind. It just will trigger anyway the notebook to run. So actually, the nice thing about using Kaggle, I could have used maybe Google Colab or something else, is that because I have my data set already uploaded to Kaggle, and then if I configure the notebook with that data set, it downloads it automatically. So these 2 cells here that you see, actually they are not needed for Kaggle because these are, if you're running this notebook outside Kaggle, then you would need to download the dataset from outside Kaggle. And you can see, right, it's a big file, so it takes a lot of bandwidth. So I'm glad that we can just upload it to Kaggle and use it. So these 2 cells would only be needed if you're running Google Colab, for example. And in that case, you would need to not only install Kaggle library, but you also need to basically download a JSON key, which allows you to then use your own account in Kaggle and download this dataset. All right, so, okay, seems like it's running now. Okay, so I'm just going to run the notebook as is. And the notebook as is basically using the old version of the dataset. And I was getting, that's the strange thing, because I used, so a dataset in machine learning has 3 elements, okay? You have the training dataset, you have the validation dataset, and then you have the test dataset, right? The validation dataset is the training dataset is the dataset with images which the model will learn from. So the model is going to kind of look at those pictures and learn from those pictures, okay? From looking at those pictures. The validation dataset are images that the model doesn't look at those pictures directly, right? But those the validation dataset is used at the end of each epoch, right? To basically benchmark the results of the machine learning model that we've trained on the training dataset. And the idea is to make sure that our model isn't cheating, because the model, if we are not careful, can just memorize everything, right? And it can overfit into our training data set, and it can get excellent results with the training data set. It can get you 100% accuracy because it memorizes every single thing about those images, right? A computer can do that very easily if you give it enough memory, right? So in order to prevent that, we use the validation data set, which are images that the model hasn't looked at and it will never look at directly. And then we use to basically benchmark the model. In that way, we can guide our training towards the right direction. Okay? So basically, if the machine learning model that we're trying to train memorizes everything, it will get terrible results with a validation data set. And then when we get to the end of the epoch, an epoch is basically a full cycle through all the different images in the training data set. When it gets to the end of the epoch, it will just give up, right? It will not give up, sorry. it will just adjust the weights and everything. It will kind of have to change its strategy, right? So we basically force the model to learn properly, like hopefully like a human being would, which is to basically just start looking at the actual features in the images that would identify, for example, a cat or a fox or whatever. Okay, and normally we have a ratio of 80 to 20%, so 80% training data set and 20% validation data set. But this ratio can be adjusted depending on your experimentation, because it's always important to remember, right? This is not a formula, right? There isn't like a fixed number that you can just use and it will work for everything. You need to experiment. Start from those like, common numbers that everyone kind of knows and everyone mentions it, and then you can adjust to what works better for your use case. Okay, let's see if, okay, it seems like I'm still, okay, 50% of the data set is being uploaded. So now I'm going to just keep running this. So I have here, this is something, a problem that became clear once I started using images from my own camera, right? The images that you have on the internet, they actually are taken by people, by photographers most of the time. And you know what? They always put the fox or the bird or the cat in the center of the frame, because that's what we do, right? We try to highlight our subject, okay? So because the pre-trained model I'm using for transfer learning, in this case, needs to have square images, right? The cropping is done the center because that's the easiest, and there is no like intelligence needed there, right? And for the images that we collected from the internet, that's okay, because guess what, right? All the cats and all the foxes and all the birds, they're always at the center of the picture. At least that's my theory, anyway. So when we trained on these images from the internet, and then when we run the benchmark against the validation data set, it was working perfect. It was great. It was awesome. It only turns out that when I started adding, so I added the third data set, which I mentioned, the testing data set. So the testing data set is something that you normally use at the very end of the training. And these are images that are not, were not included in the training data set, okay? And the idea is you have another independent measure to make sure that your model has learned well and it can generalize. So what I did, I used for the testing data set, I used pictures from my garden. But they were so different because my, obviously it's just a camera that is sitting there. I'm not just moving the camera so that the fox is at the center or the bird is at the center. It's just there, right? So if the fox is on the edge, it is on the edge. It doesn't matter, right? It's still there, the fox. But the problem is when you crop that image, because you're cropping at the center, you lose the fox. So I was getting terrible results because of that. And then what I did was, okay, let's find another way of scoring our images. because that's actually if you're using a pre-trained model, it's almost like a hard requirement. You have to square your images. I did a bit of research here on a live stream, and I tried to find if there are other easy ways to accept non-square images. There are ways to do it, but it involved me trying to hack the neural network, right? And I think for the I wouldn't go with a solution like that before I try the easier one. So the easier one is to just square the image with padding. So basically we add in black bars. Okay. So that's why you have this method here to square the image. This is using OpenCV. Okay. Almost uploaded. All right. Now we have this method copy files. So I created this method here to make sure that I control how many images I'm using from each image class, right? Because for instance, you might have like 3,000 or 4,000 images of cats, and then you only have like 500 foxes, right? If you just use all the images from each folder, from each image class, then you end up with an imbalance. And it's normally good to have some kind of balance in your data set. Like, it's not like a hard and fast rule. It's something that you need to, it's like another hyperparameter that you kind of have to work with, because you know, at the end of the day, you need to try and adjust what you want to. You can adjust those numbers, like those proportions of images, and based on what you're trying to detect. But anyway, right now I'm trying to have a fixed number, and you can see it will take 500 images from each folder, from each image class, classification. If for each class we have up to 500 images. Okay, so now, and these two methods here, we are calling the copy files. And this is from like the last live stream. So I'm copying images from this. This was a bit hacked, to be honest, because anyway, I use the data set from the internet for training. Yeah. And I use the data set from the Pi for, I ended up using it for the validation. These names here, ignore them. I need to adjust them. They are misleading now, because after some experimentations I tried to use, the first combination I tried to use was, okay, training and validation from the data set that I collected from the internet. And then I used the test data set with images from my Raspberry Pi. Okay. Another combination I tried to use was and this is the one I last tried, was to use, okay, it didn't work very well. So I decided, okay, let me just try and instead of using the validation data set with images from the internet, I'm going to use the images from my Raspberry Pi. And hopefully this will guide the training towards a place where you can detect well, make good detections with my own images. But it turns out that it didn't really work. So it had a really bad accuracy on the validation data set. And it didn't go anywhere. It wasn't really progressing. But then I realized, okay, I don't have that many images. I have only like 100 from my own camera. So I had to collect more. And that's why I'm uploading this. It just finished, thankfully. So I'm going to create, I'm not going to use the previous one. Just going to create a new one. Okay, so it will take a few minutes to process, and let's try and run this. Okay, so I can show you at least how it was, how badly it was doing before I used the new dataset. There's some annoying error messages as well that I'm getting in TensorFlow, but I think that is a bug. Often you'll find bugs in TensorFlow. But this is more like an annoying bug rather than a serious bug. Okay, here you can see This is from the dataset on the internet. And this is from the dataset that I had for my camera, right? Which was tiny. Okay. So obviously, I think that the problem was I didn't have enough images to actually train to use this for even for validation dataset only. Right? You see, these are the pictures that someone took, right? Okay, it's not dead on the center, but it's quite close to the center. So even if I crop this, so these are images from the internet. And you can see the black bars being added now. Now we have, what's this? It looks like a rabbit almost. Like a rabbit and a fox together. It's a very strange fox. Anyway, you can see center. And then you have black bars. Here it's actually not going to help that much, but never mind. But everything has black bars now. Then the birds the same. Cats as well. And you can see cat right on the center. All right, so now I have this method here. This is a keras, TensorFlow keras method that makes things easy for you. It loads everything. You pass in a directory and you just specify shuffle equal to 2 to mix everything up. Then you say how much of a batch size. And this batch size is basically the number of images you want to train in each step in your training, right? So in this case, the batch size is 32. That's a common number, a magic number, but you can change depending on how much memory you have and how quickly you want to learn. And I think I've heard that a bigger batch size is better because it can average the weights, and it can do better averages with more data at the same time. But anyway, and then image size. Okay, this depends on your model. Okay, you need to check if you are using a pre-trained model and you're doing transfer learning on it, you need to know what image sizes it accepts. And for this one, I'm using MobileNet version 2. It accepts this is the biggest image size it accepts. So it's 224 pixels squares. Okay, so now I'm going to run off time, right? I talk so much. All right, so you can see a sample of the images. And these are all from the internet, all nice in the center. And at some stage, you will see images from my own Raspberry Pi. So we're doing a training. So this is training data set and a validation data set. Okay. This is still using the images from the internet, I think. Okay. So now we have the image augmentation, very important, right? Especially when you have a small data set, you can use image augmentation, which is more generically called data augmentation, right? And in keras, you can do it very easily, right? I have two here, very basic ones defined by default. I copy and paste it. But I can, once I'm kind of more confident in what I'm doing, I can add some more augmentations here. One that I'm planning to add, if I don't get good enough results, is to add some. There's one for increasing the brightness or decreasing the brightness, and it makes sense for me because my garden has different light levels during the day. Okay, so it's always good to make sure that the model is not expecting everything to be nice and bright, right? Because when it gets a bit closer to the darker times, right, you want it to be able to detect something still. Okay, so here, okay, I won't go into detail for this code. I've already gone through that in another live stream, but I have to go through this code again today. So I'm going to be quicker now. Then I can explain things. If you have any questions, let me know. I can always stop and explain what the code is doing. I took a lot of this code, by the way, from the Tensorflow tutorials. So it's always a really good place to start from as a starting point. So we have, so this training is going to do 10 epochs. Right now, what this is doing is just doing an evaluation of the model without even doing any training yet. And you can see the accuracy is very low. Now we're training it. And I believe this is not with my, this is not using my images yet. You can see that the accuracy is going up very quickly and the validation loss is going down quite quickly, and the accuracy, validation accuracy is going up quite quickly, which is good. So the validation accuracy is the accuracy that, as I explained before, at the end of each step after training, right? After going through the images in the, well, at the end of each epoch, actually, after going through all the images in the training dataset, then we benchmark the model against the validation dataset, and then you get these two numbers here. Okay, and you can see it's perfect, right? It's great. So if I had to only identify foxes on the internet, I think I would be quite confident to be able to use this model. And you could use it for something useful. You could just maybe, I don't know, do a classification of images on the internet based on this model. But unfortunately, that's not what this model is not good enough for me, and you'll see why. Because when I run this against my own validation data set, it's going to be terrible. Okay, this is just still showing how good it is when you use images from the internet. It's all good. Everything almost accurate. And you can see a benchmark compared to before. Before we trained, we had a very low number, right? And now we have a high number, right? High accuracy and low loss, which is good. Now here, and this is where it goes wrong, right? So I use the training and validation from the internet. It's all good. Then when I benchmark these against my images from my garden, right, I get like a very bad result, and you'll see. So this is the annoying bug in TensorFlow. It's always showing clean up. Okay, and you can see. So, okay, this one's actually correct. Bird. It's a bit tiny, but I can guarantee you this is not bird. This is like a fox there at least. Let me see if I can make this a bit bigger. Anyway, I just don't spend too much time on it. Anyway, you see everything is like leaning towards a bird. Like it's saying that this fox here is a bird, and so it's giving bad results, okay? And we can actually get actual figure, right? You can see that the accuracy is very low. The loss is very high, so this is not good. Okay, so I don't know, this was something I was demoing the other day. That's not really important. So here, the last experiment I did, and this is where I kind of stopped before I started gathering more data. And I tried to use my test data set, which are images from my garden, as the validation data set as well. So now we have training data set from the internet, validation data set from my camera. And I thought it would actually get better results because I kind of using, I was hoping that the weights, when it gets to the point at the end of each epoch where it has to adjust the weights and all the hyperparameters, then it would take into account the images in my garden, and it would try to change those weights to get better results on my images. But it didn't go anywhere, so too bad. Right. So we're going to train it, but you'll see that this accuracy, okay, the accuracy on the training dataset is going to be very high, and you can see already it's very high. Maybe because we haven't started training from the beginning again. Let me just see. There might be an issue actually, so I might want to. I think I want to try by. Let me see. Model. I thought I started from the beginning. It feels almost like it didn't start from the very beginning. That's why I'm just double checking. But I think I did start from the beginning because I made sure everything is initialized again. So should be okay, right? That's why I probably should create a new notebook just to make sure that I don't have previous results interfering. Inputs and outputs. Yeah, I think it's all new. Just to understand why it started so high anyway. But you can see validation loss and validation accuracy, which are now running against my own data set. They're quite. It starts quite low, right? Even though the accuracy is quite high on the. This is what the model is doing against the images that it's training on, which makes sense, right? And this is how it does against the validation data set. And the problem is it starts bad and it doesn't go anywhere. Yeah. Okay. It's quite bad. The only doubt I have is whether I have something that. Yeah, I think it's fine. All right. So now I'm going to change my data. Check for updates. So I'm going to update my data set. I'll have to modify the code because some of the folder paths are going to be different. So it has downloaded all the data. So I'm going to restart the notebook just to make sure that I have nothing from before still running. Restart and clear also outputs. Okay, so now Going to run this. You can see that our folder structure is different now. This is like internet dataset and my garden dataset. It's very clear what the difference is between the two. And I think for now, I want to try and keep the notebook in a sequence so that we're able to go from a point where, to just follow the sequence and how I trained this. But maybe I should just create a new version of the notebook. I don't know. I'll see. I just want to make sure that my previous training doesn't affect the other experiments I'm going to make. Okay, so now we can see this data set. Now this shouldn't work, right? Okay, because I still have output here. I think what I'm going to do, should I just... I don't know if I should just start a new note, release this notebook, because I don't want to have any code. I'm going to clean up this. Just so I have no surprises. So this will do it everything. So this folder is no longer there. Okay, I can remove this now. And then I can copy the files. But the inputs, so I'm going to do input Raspberry Wolfpack, dataset, dataset. So this one, internet dataset. So at the same time I'm copying the files, I'm also reducing the size to what I need and squaring them with black bars. So I have dataset pi, copying. Now, just make sure the folders are correct. Then dataset. Did I make a mistake? Maybe I... Oh, I'm going to keep the names the same just to be consistent. Right, so now if I count the images, I'm not finished yet. Still going. Okay, I think it's finished now. So now I count. I should have the number of. Okay, so I have from the internet dataset, I have almost 500 images of each. Then from my own dataset, I have a rather low number of birds, but I don't think I care too much for now. And I have like, I mean, I have more cats than this and more foxes than this, but the copy files will max it out at 500. Now, okay, what am I doing wrong? Okay, the paths have to be updated. Internet dataset. So what I'm going to start doing is I'm going to name these more appropriately so I don't mix anything up. So instead of just saying train directory, you can call it I'm just going to call it internet dataset dir. Yeah, so that because now I'm going to play around with these data sets. I'm not going to always make them, I'm going to swap them around. So it doesn't make sense to call it train dataset when I might not even use it for train dataset later on. So internet to train their path. What's the difference? Oh yeah, the path, leave path, okay. Count. Okay, so it still works. Just have to update all the paths. Now, what do I do with this? So I can call it internet like that for now. Excuse me, I think I might have to. Right, I had to save it from here and that. So I need to update this. You can see. So the internet data set looks very nice. Everything at the center, as you would expect from when someone takes a photo of someone they like. Cat owners are very proud, you can tell. Sure, everything is up to date. And now here, okay, this is the actual one that's used for training. So I think so internet dataset train, and then this one val. Okay, and then the paths internet datasetter. You should be able to. So this method takes 80% of the images because of the validation split that you can see here. So validation split means that 20% validation. And here we're specifying what validation, what data set is this. This is the what subset this is of the data set is training. Okay. Then the seed number, it's important because if you want to make sure that you get different images in the other data set, you have to use the same seed number here. And everything else is the same. So, but the difference is instead of getting all the images, you get the other 20% in the second one. This is a really strange bug. If I run this again, it works. I don't know why. So you see 1,180 files for training, 295 for validation. Okay. Just going through the notebook, making sure everything works. Okay, I think I forgot to change the names here. Let me just check. Okay. Internet. What's it called now? Internet DS train. This is we are just building the bits and pieces of the model. So we are using a pre-trained model, which is in this case is MobileNet version 2. Okay, we're only using the bottleneck of this model, and what that means is basically imagine you have a bottle, and you take basically everything above the bottleneck. So the bottleneck of the bottle, you take it. So you take that away, and you only have. So basically, you take the last layer, which is the top layer, away, because in the case of MobileNet, by default, it's a pre-trained model that has learned on 1,000 different image classes, right? So we're taking that layer away that can classify between 1,000 different classes, because we only need to actually classify in this case for 3 classes, right? So we don't need that layer. So we take it away, and we put a new layer in. Actually, we're not just adding a new layer. We are also adding global average pooling, a global average pooling layer, and a dropout. And these are this one is for regularization, and this is to prevent basically the model from memorizing everything, so it drops connections from the neural network randomly, and 0.2 is a proportion it does on that. Okay, so let me run that. I think I have. So the model is being built here. Now the learning rate is how much of a shift we make every epoch. You know, when we change the weights. and we're using the optimizer is Atom, and then we use the sparse categorical in cross entropy, which is normally used for when you have different categories you want to classify on. If you only had like two, for example, like 0, 1 or true or false or whatever, you would use something like binary cross entropy. Okay. Right, now let's do this. I'm just going to go a bit quicker now. Okay, let me just make sure I didn't use, okay, this is, I need to change this. So internet dataset val, just to work as it used to. While that's running, I'm just going to try and off. Okay, so now I'm going to change this to replace, continue replacing the variables. Okay, so this is okay, I think. Right, you can see cat, bird, fox, cat, fox, bird, cat. Everything's correct here, as you would expect anyway. Now, this is when we start using our garden dataset. We're going to use it for the test here, as we were doing before anyway. And this is just to show how bad it is against when we're using images from our Raspberry Pi camera. And I need to make sure I'm going to name this appropriately. So my garden set. I have an error. Does it only have, anyway, I'll put the full path. Seems like, what happened there? Oh, it's a bit more levels than I anticipated. Just Yeah, it's terrible results. Everything almost like a bird. So yeah, this is really annoying. I hope they fix this bug in TensorFlow. I tried to switch off the or reduce the level of debugging, but it doesn't work. It's a bug. Okay, so now I don't know if I should just copy and paste just to be sure. I think it should be okay. I'm going to. At the end of the day, it's called my garden dataset. It doesn't have to be test. So the thing is, did I use a? I'm not using the whole. Too many images. No, it's too many. Let me just try it anyway. Oh, I'm going to call it. I'm going to just make sure that all the variables are different. We do that now. Just have to make sure that I'm not using any variables from before. Prediction layer. All good. This one I can do. You could call it experiment 2. Let's see. Internet dataset train. So this is for training. Then this one is for the validation dataset. It's defined it. It's here. So why is it not accepting it? Sometimes I don't understand what's going on in Kaggle. But accuracy quite high from the beginning, and that's what I'm not. But maybe because I'm using a very strange combination of. Okay, I'm not surprised. It didn't go anywhere. Okay, so now this is where I add. I'm going to add more code, and this is where I'm going to do my experiment. So I'm going to copy and paste this. I think I'm going to try first just to train only with my own data set. Yeah. It's something I want to avoid, but I want to try first and see if I get immediate results with that. So I'm going to call this train, and I'm going to use the formula to add some extra properties here. I'm going to call it. So I'm going to add the validation split, the subset, and the seed. I think I also need to add the shuffle as well. Oh, it's already there. Okay. So validation split, I'm going to leave it as the standard for now. I'm going to call this validation. This is going to be my training subset. I can leave the seed the same, doesn't matter. And then val. Okay. So val. What's the validation? Okay. I don't know if it's training or train. Let me just check. I mean, if I train on my own dataset only, and I use the validation dataset also from my own dataset, I don't see why I shouldn't be able to get some good results. So validation split. Okay, this is all correct. Okay, it's fine. So I have my garden dataset train and the my garden dataset val. And you can see, so we have about 1,000 images for training, and we're using 247 for validation. Maybe that's a bit small, but we also have image augmentation on top. Don't forget that. Oh, and then I have to go. Image size as well. I need to copy that later. I'm going to copy this. I have this here. So I'm going to add another cell. I'm building a new model. So data augmentation, pre-processed inputs, the image shape. I'm going to keep it the same as it was before. So the mobile net model. So as I said, right, we are using MobileNet version 2, and we are removing the top layer, which it's quite convenient here. You can just say include top equal to false, and it will do that for you. Then weights equal to, so ImageNet is the data set on which this pre-trained model was trained on. I don't know if it has other weights available. We could check that later maybe. Now we have image batch, label batch. Okay, this is just showing some shapes so we kind of understand data set. So 32 is a batch size. 7 is what? I forgot. This is a number of features that are coming out of the model, the base model. Yeah, this is what is showing us. 7 times 7. It's like a cube, I think. Anyway, 1,280 is the. Actually, that's the. Feature batch. Just checking all the shapes. 224 pixels square. Anyway, this is from the base model. That's a shape from the base model. Right. Okay, what comes next? Now, you can see, right, we are setting the base model trainable to false because we want to train, when we train the model, we don't want to any of the weights that were part of the pre-trained model, these ones, to change, right? We want to keep them as they are because otherwise we would have to train for a much longer period of time. Okay, so now I'll copy this bit. I'll copy this as well. And then I'll copy this as well. Just so I just have to do it once. So I'm doing everything once, one place. So this is building the actual model. I'll organize this later. Be here. Now, so the model is built here, and I'm going to make it experiment 3. And then let's run this. So this is for, I need this, this. And here I change this to my garden dataset. So everything will be my garden dataset. Okay, and we're very close to actually running some code. Let's see. Fingers crossed that all this time gathering images is going to bring any fruits. It's done for today. I'm hoping you just have some good results to feel good about tomorrow. Okay, it's interesting. Maybe I haven't trained long enough, but this is actually better. The validation accuracy is getting much higher. I've only trained this for 10 epochs, and the loss is still quite high. So I think I could just train this for a bit longer. And maybe I won't start from the beginning again. Let me just initialize everything so it doesn't. I'm going to call how many epochs? Why does it say that? Initial epochs. Make it equal to 20. Let's do 20, right? And see if this number of the accuracy was 0.77 on the validation dataset, which is much, much, much better, right? So I have great hopes for this. I haven't run it yet. We have to fix this bug because it's get easily lost in a notebook. I don't know where I am now. To clear cell. We want to. Okay, so let's run this again. And hope that. Okay, so you see, it starts with a accuracy that's on. You can see validation loss, not too bad. Validation accuracy 0.78. I'm pretty sure now we have better results. Okay, what we have to do actually, because we don't have a separate test data set from my own camera yet, I'll need to benchmark these again at the end. I'm going to just use the validation data set that I use for training. But that's okay for now. Then I will, at some point, I'll maybe gather a few more images so I can have a test data set, and then I can see if the model itself is not, it will be able to, well, it should do well in images from my garden, right? But so, okay, so now, I don't know if it's finished or not. So the validation loss is still, I think can still get smaller, right? So we have a validation accuracy of almost 80%. And how many epochs we have trained on? So much rubbish. I can train this more. So I've done 20 epochs, 40 epochs maybe. And then I'll leave it at that because it's already a long stream and I need to rest. So I'm going to put 40. Oops, cancel. 40. You see, I can play with these parameters. For now, I'm just trying the easiest and to see at which point I can draw maybe a graph. In the next live stream, I'm going to draw a learning curve that you can see the loss graph and the validation, the accuracy graph, and then we'll be able to know by looking at the graph, okay, whether we should be able to train the model any further or not. right now, but it's just by eyeballing it. I think I can train this for much longer. I need to. So we need to wait until it's finished. In the meantime, if you have any questions, let me know. Oh, don't forget to click the like button while you're waiting. If you like the stream, um, that will help me as well. It'll help the stream to reach more people. Will be greatly appreciated. The accuracy is quite high on the actual training data set. You would expect that because that's what the model is learning those images, so it has no problem learning from those images. In fact, in general, a machine learning model will overfit quite easily if you let it. So that the issue is never about training on the images themselves. It's always you should always pay more attention to the validation loss and validation accuracy. And that's why we use regularization a lot of the times. It's just to try and avoid the model to learn too well from the images that we give it for training. Because the more it overfits into the training data set, the less well it's going to do with images as it hasn't seen before. It's a bit like memorizing for a test, and then you get a slightly different question, and you don't know how to answer because it's just slightly different. Validation actually is quite high now. It's actually quite good. So I'm quite. What did I just do here? Because I thought I had. Did I copy this the wrong place? Okay, I think I changed the order by mistake. This is supposed to be at the after. It's okay, it doesn't matter because I ran this cell before, then I run this. Okay, right. So now we have some really good results, and I'm going to just copy the code that we have used before to benchmark our model. Like, first of all, let's do a visual benchmark. So it gives us, I like to see it, to believe it first. Where is it? Okay, here, just copying. So before we did terrible against our garden images because the model just wasn't used to it. Okay, so copy this. It's using matplotlib. It's always useful to learn matplotlib. Okay, now we have, okay, my garden dataset. Anyway, as I said, I'm using the same validation dataset just to do this benchmark for now. And I need to make sure the model is correct. So this is experiment 3. And okay, I think it should be okay now. So I'm using images from my garden dataset. I'm benchmarking against those. And I'm expecting to see good results because, oh gosh, it's so big, small. But this is a bird. I think I can see a bird here. This is a cat. I know it's a black cat. A bird. Yeah. Okay, I think you got it wrong here. This is a cat, a fox for sure. I can't tell because it's too small. And then we have the cat. Maybe I can still get higher scores. Folks. Oh, this is so tiny. Okay. All right. So this is the visual benchmark. And I want to just do a proper evaluation with the number. And we can wrap up for today. And then in the next live stream, I'm going to do more experiments. I'm going to mix the two data sets, and I'm going to see if, first of all, I think this model can still get better, even though the accuracy is, the validation accuracy is already quite high. I think it can get better. And this is good, actually. I think I can deploy this already on my Raspberry Pi. So I won't be spending a lot more time trying to do experiments. I'll do some, and then I'll try to deploy this as soon as possible, because with this level of, this is not, I think it's evaluating the wrong model. 1 second. This is just looking bad. So experiment 3. Okay. And I'm going to use first this one. You can see the accuracy is quite high. Yeah. But it can get better. 95% is still not good enough, in my opinion. Okay. This is good. All right. I hope you enjoyed this live stream. And then, yeah, I hope to see you again in the next one. And until then, happy coding.